the field operations viewing and using the data that is captured and managing that data. So we've got Paige Tucker, who's the CEO of ProStar GeoCorp, that has this sort of end-to-end solution. And Paige, if you could introduce yourself and go right into your session. Thank you.
Thank you, Gavin. What I'm going to discuss here today is mapping the underground. I'm going to talk a little bit about where the industry currently is, some of the business practices that are being implemented. And then, as Gavin mentioned, I'm going to share with you the ProStar solution and how we've developed a cloud and mobile solution to enhance the ability to map the underground. And then I'm also going to peek around the corner and show you what I think is coming in the not too distant future. Again, my name is Paige Tucker. I'm the CEO and founder of ProStar. We specialize in the development of precision mapping solutions, and we've developed a cloud and mobile solution that I'm going to go over with you today. First, let's take a look at infrastructure and what we mean by infrastructure. When we say infrastructure, in most cases, we're talking about a vast network of surface infrastructure that crisscrosses our country and is comprised of our roads, bridges, and highways. This surface network is critical, of course, for supporting our businesses and industries. And it's a well-known fact that this infrastructure is becoming dilapidated, and it's in serious need of repair, replacement, and expansion. We know that currently government's talking about spending anywhere up to $2 trillion in order to overhaul this infrastructure to get it to acceptable levels. Just some statistics, just to go over. There's 2.65 million miles of paved roads and highways that we rely on every day for our for our commerce and commuting demands. The majority of that infrastructure was put into the ground over 50 years ago. And recently, the American Society for Civil Engineers gave it a D+ rating, which is obviously very poor. But there's a whole nother infrastructure that's out of sight and out of mind, and it's the infrastructure that's buried below the ground. This infrastructure, of course, consists of our oil and gas pipelines, water, sewer, storm systems, telephone, fiber, electric, and cable. Just to put it into terms here, as far as comparison to the above ground infrastructure, there's 35 million miles of underground pipelines and utilities in the US alone. And a vast majority of this subsurface infrastructure was put into the ground over 60 years ago. For example, most of the nation's water pipes have been in use for almost 100 years. Every year, there's new additions that are going into the ground, a result of how many homes are being built. There's over 850,000 new homes built every year in the US. As a result of that, there's 50,000 miles of new gas lines that go into the ground. 250,000 miles of new telecom cables are going into the ground, and 280,000 miles of new water lines. So let's take a look at the problem with all of that construction and all of those annual additions. Anytime you add, repair, or replace the surface or subsurface infrastructure, you have a chance of damaging a utility or pipeline that's buried below the ground. In the US alone, there's over 500,000 strikes that are recorded, and that number is growing. And of course, every time you hit a utility or a pipeline, the lights can go out, traffic is disrupted, neighborhoods can be flooded, gases are emitted into the air, and far too often there's serious injuries, including loss of life. So let's take a look at the data sources that are currently available for these utilities and pipelines. Utility and pipeline owners, for example, don't know exactly where their assets are buried without any real level of confidence. In other words, they don't know exactly where those utilities are buried below the ground. The records are old, they're outdated, they're lost, or simply never existed. And any records that do exist are often of inconsistent quality and content. As you can see by the picture below, most of them are in paper formats. These records are in different data formats and often incompatible for sharing. Most of the information being provided is in what we call as-built drawings. And this is an example of on the left-hand side of an as-built drawing. But in some cases, they're very rudimentary sketches that are being provided, which really don't provide any real good information as far as where those lines are buried below the ground. But these are the sources of data that we're relying on today. The current process to reduce damages on utility lines is a process that's called 811. And 100% of construction projects are required by law to identify and mark the location of the utilities and pipelines before any digging occurs. The process today is, again, what we call 811, and every state has an 811 call center. The locations of the utilities and pipelines are provided by the utility and pipeline owners, and these pipelines and utilities are located and marked with paint or flags, and I'll show you that process. So the current method is you go out and use what's called an electronic magnetic locate tool that can identify where the approximate location of the utility is or the pipeline, and then they mark it with paint or flag markings. And you can see in the picture here all the markings that are on the ground, and this is what the construction crews and the excavators use to determine where those lines could be buried and where they need to avoid digging. This is an example of what it looks like with all the markings on a street, and I'm sure many of you have seen these markings on the street. This is basically to map out where the utilities are buried below the ground, and it's a well-known fact that the variance level on where those markings are 3 feet on either side. And as I show you here on the right, you can get a lot of utility lines within a 3 to 6 foot area, and they're often buried on top of each other. This is where the issue lies. Let's just take a look, for example, at New York City. Underneath 6,000 miles of asphalt lies thousands of miles in utilities and pipelines. And each year, to facilitate construction and repairs, the streets are sliced open over 500 times a day. And every time anyone slices open the streets, contractors are required to call into the state one call center to identify the location of the underground infrastructure. And yet, every year and every day, these lines are hit, and the estimated cost is over $300 million a year, and that's just New York City. So let's take a look at ProStar's solution that has been developed to enhance these processes and have the ability to precisely identify, capture, record, and visualize where these utility lines are buried below the ground. And what we have developed is a cloud and mobile solution. The cloud solution is what we call Transparent Earth, and the mobile data collection system is called PointMan. So PointMan is designed to enable field personnel to capture the precise location of utility lines by pairing a standard mobile device with the locate tool and a GPS receiver. This gives you the ability, using the EM locate tool, to not only identify where that utility line or pipeline is buried, but actually capture the precise location by also integrating into a precision GPS or a GNSS receiver. Transparent Earth is our cloud application where you can actually view all this information that's being collected in the field in real time in the office on either a laptop or your desktop computing system. So just for example, as you're locating where the line is, we actually digitally record the precise location of where those lines are. And then we capture what's called the precision and pedigree, which is actually all the information associated to that locate, including the depth of cover, the currency, frequency, what type of receiver are you using, the date, the time. We even capture how many satellites are in view. And that information in real time is also available on the desktop through the cloud application. And then you can take all that information and you can compare it with your historical information in either your GIS or CAD system, and then you can consume this information seamlessly to update your records. We also integrate into the state 811 systems, and we provide the one-call ticket out into the field so that when you're out in the field, you can actually see the parameters of where the ticket is to make sure that you're locating inside the one call ticket area. But we also provide what we call geospatial intelligence, which means that mobile device knows if you're standing within the one call ticket area, and then we can provide all of the data from that one call ticket out to the field user. And what that allows them to do is, if he has to fill out, say, for example, a form, instead of doing it on a piece of paper and using a pen or pencil, what we can actually do is provide a digital form, what we call an e-form, and then with the information that's being provided from the one call ticket, we can even auto-populate the form so that he's not required to fill out any information. And then we can also provide photos and sketches. So for example, you can take photos that are geo-referenced. You can add notes just using voice to text. Instead of doing sketches on a piece of paper, you can do sketch on the satellite imagery. And then you can email that information back through the cloud system, back to the office, so that the office personnel or someone that's managing the project can also view this data. So they can see where the lines have been located. They can also see all the images that you're providing and the sketches. And if there's some type of anomaly or something that's of concern out in the field, say for example, you took a photo of maybe a sign that was broken, or maybe there was some discolor on some foliage, which meant maybe there was a gas leak. We also integrate into Google Directions so that you can send field personnel back out to the location of where the photo or the sketch was taken, which will get them precisely over top so that they can, inspect it and make any changes that might be required. One of the things I'm really excited about is the fact that ProStar just partnered with Trimble, and we're integrating into the Trimble hardware, their GPS and GNS equipment, including a new product they have called Catalyst. This is a $350 receiver, and when you combine it with our PointMan application, you have the ability to precisely capture the location of these buried utility and pipelines down to the centimeter. And Catalyst literally works anywhere in the world using the Trimble network. So now, if you integrate the EM locate tools with our PointMan mobile solution and Catalyst, you have a very low-cost solution, which again allows any companies to be able to capture, record, and visualize where these utilities and pipelines are buried virtually anywhere in the world at a very low cost that's no longer prohibitive, if you will, as far as the expense that was required previously to get down to levels of centimeter accuracy. So what's next? Well, I think what's next is having the ability to precisely capture and record and visualize where these utilities are buried below the ground. I think that we're going to be able to leverage new technologies, including the ability to provide three-dimensional view of the precise location of these utilities. What that would allow is the field crews and also the excavators to have literally a three-dimensional view of what's buried precisely below the ground, which would significantly reduce the amount of damages that currently occur on a daily basis. So for example, we could take ProStar's cloud and mobile technology and combine it with augmented reality, including Trimble's new Sight Vision, which is that device that I'm showing you on the right-hand side. So what that means is, using technologies like PointMan's data collection system, we could precisely map where the location of these utilities are, and not only see where they are on the mobile device, but through augmented reality, literally anybody out in the field could have a three-dimensional view of the precise location of where these utilities are buried below the ground. And as a result of that, I think that the next transition would be to have heads-up display in the cabs of the backhoes of the excavating equipment, which would provide a three-dimensional view of where the utilities are buried while the excavator's digging. And if there was encroachment and the bucket of the backhoe was getting too close to a utility line, you could easily provide a warning of what line they're encroaching on and what information would be required, including the contact information, to have the asset owner come out and expose that line if necessary to make sure that that line's not hit. So again, in my presentation, I just wanted to give you kind of a view of where the industry is today in terms of mapping utility lines. Some new technology that's being developed, including by my company, ProStar, but also some advancements in technologies and through strategic partnerships with companies like Trimble, where I see things going in the future that could dramatically improve business practices so that we could avoid hitting these utility lines that, again, happens far too frequently and on a daily basis. So with that, I conclude my presentation, and I thank you, and I'll take any questions that you may have.
Yeah, thank you, Paige. You were very efficient in your presentation, so we actually have quite a bit of time for questions. So we will get all of those addressed directly to your presentation, and we may catch up on some that we had to miss in the previous presentations. So yeah, thank you for outlining your solution. I think it's quite cool. You've got this end-to-end. You've got both ends of the field, the collection and also the end use, the visualization, and as you said, tying in that data with other systems like geofencing for the construction equipment. That's you know, that could save a lot of the clash, you know, problems with the clashes. So into the questions, somebody asked they'd love to implement this for their jurisdiction in Chile, and he said, but you know, what brand do you represent? Or, you know, one of the big geos or another, to avoid problems with companies that sell the same in Chile. But I think, you know, you could answer that. You're your own brand. That's correct?
Yeah, so what we did is we developed, again, a cloud and mobile solution using open data sourcing. So we can actually integrate into any existing hardware or software that currently exists. And our goal is, to, if you will, to put a wrapper on it and just enhance some of the current business practices that are being utilized. So we work with literally any hardware or software that's currently on the market.
Okay, excellent. So here's a question, digging down into the details, because when there's, you know, a 3D representation of the utilities gathered by multiple methods, GPR in particular, or the magnetic, you know, how do you identify and verify which utility is which? I'm sure that there probably needs to be, you know, correlation with records of what was put in the ground to identify which utility is which. So, you know, because the attendee was saying in the PointMan, you see the different utilities by color code. How do you get to that distinction between them?
So there's several ways of locating the utility line, and the presentation previously discussed that. For example, GPR, and I'm not by any means a GPR expert. The main source for data on the PointMan application is we pair with an EM locate tool. And EM locate tools can pick up unique identification of a utility line, and it can identify if it's actually, say, for example, a cable line or a power line, telecom line. And then if it is made of metal, then what they'll do is they'll put a charge on it electronically. Then you can identify, say, for example, if that is a water line or a sewer line. So most of the information that we're depending on as far as capturing where the utility line is buried is coming from the electromagnetic locate device, which actually can identify and determine what type of line it is. As far as GPR, GPR does require some post-processing and interpolation of the data from an expert, but I'm by no means an expert on GPR.
Cool. More questions? What's the capability for the products when you're out of cell range?
So actually, PointMan is designed to work offline. We know that there's a lot of areas where you're working remotely, especially in the oil and gas industry. So we developed it to inherently work offline. And in fact, what it'll do is, in some cases, even if there is just interruption on cell communication, basically what it's constantly doing is caching all the data that's required to continue with your workflow processes. So regardless if it's disruption or you're offline, it's designed to not require cellular communication.
Excellent. Yeah, working disconnected. So question about when you got utilities exposed during excavation and installation, what would the process be with the PointMan and the software for capturing that data?
That's a great question. So we're actually working with some of the largest companies in the United States that actually build infrastructure. And what they do is, for example, when a utility line is exposed either by the excavator or through the hydrovacuum process, then what you do is you can just take a pole utilizing the GPS and GNSS and the PointMan application, put the pole on the line and then capture it. And then you have survey grade quality data that can then be utilized to update all the records that are once again currently in maybe a GIS or a CAD system. Okay,
Jeff J has Jeff Jacobs, who's a contributor to XYHT. He's the geo dude, a scanning expert. Jeff says, what is typically the biggest barrier for prospective users to purchasing and deploying these kinds of systems?
Well, as I mentioned, I think in the past, a lot of the systems that have been developed require a lot of education, if you will, in order to understand how to utilize them. And I think in some cases, even some of the hardware that was required to get down to precision levels of, say, just a few centimeters was cost prohibitive. The way that we've developed our system, we literally tell everyone, if you know how to use Facebook and you know how to use Microsoft Office products and you know how to use Google Maps, then you inherently know how to use our system. It's very intuitive. We can have you up and running and trained in a matter of one day. And then as you can see with the advancements of technologies, and that's one of the reasons I wanted to bring up the Trimble Catalyst, where in the past, where it could be required to spend tens of thousands of dollars to be able to have equipment that could get you down to centimeter accuracy. Trimble's now releasing products like the Catalyst that's $350. So PointMan, for example, is under $500 and the Catalyst is $350. So that means for under $1,000, you have the ability to precisely capture, map, record, and visualize the location of where these utility lines are down to the centimeter.
Okay, yeah, thank you, Paige. Hey, Paige, I need to make a clarification about the Catalyst. As you know, I was an early tester and we published our tests in XYHT. The antenna is $350. That's the hardware that you have to buy. Correct. Which is actually a really good deal for an antenna. It's not a geodetic grade antenna, but it's great for field conditions. But the receiver itself is software defined. You run it on the processors of your phone or tablet. So you can use a phone or you can use one of these hardened tablets, and you download that software defined receiver, but you use it authorized through a subscription. The neat thing is there's lots of models of the subscription. You only need to pay when you're out there using it. And there's credit systems and things like that. So yeah, the hardware investment is very low, but you are going to be paying over time to get that high precision. Fortunate thing about it is that it is capable of survey grade precisions in most conditions. Not quite the same as a geodetic antenna, but it's pretty good. anyhow, sorry about that. I had to make that distinction.
No, that's
You know me.
that's a good point. And I was aware of the fact that there is a subscription agreement that's required with Trimble. But from my understanding, it's very user-friendly because they're doing it through on-demand services. So for example, if you need to be out on a project site for say 3 weeks, then you can pay for that services just during that 3-week period, which again, from my understanding, is very cost-effective. But at the end of my presentation, you'll see that I have a slide in there. We're working very closely with Frontier Precision, which is Trimble's largest distributor of Trimble equipment. And I've left the information down there for Frontier Precision because again, I'm by no means an expert on Trimble equipment, but they can contact Frontier Precision and they'll be more than happy to answer any of their questions. Also, you'll see at the end, what I've also offered any of the attendees is I'm more than happy to provide to them a free version of PointMan, which is, cost of $495. I want to give it to all the attendees for a year so that they can use it and familiarize themselves with it. And it's not required to buy a precision GPS. You can just utilize the GPS that's actually just part of your mobile device as well.
Cool. That's a generous offer. Yeah, the more people that try these things out, the better. I encourage people to do this. So yeah, the only reason I brought that up was somebody sent me a question and said, is it really a $350 receiver? Well, yes and no. So going back to the questions,
Gavin?
Yep.
Hey, this is Rob Martindale from Colorado.
Yeah.
I just wanted to add a little bit to this discussion about the DA1 and the service because we are running the Trimble DA1 on a free VRS network without subscription. So there is a way to tie that DA1 into a VRS network and through PointMan and pair that up and run on it if you have that available. So there is a free option. It just kind of depends on where you're at in the world and what VRS networks are running. That, for example, Western Colorado has a free network that was established through core stations, and with the login to that network and that antenna, we're getting centimeter accuracy without Catalyst running.
I see. Yeah, I see that. And so there's no subscription for the use of the software-defined receiver. I understand there's a difference between VRS networks, which is the correction source, some being free and some not. Maybe I got to shelve this and we can get some clarification. So getting on to the subsequent questions here, Joseph P. says, is there an ability to make notes at a point that is being captured as the line is being located, like the IE, the shot number, other needed notes? I think you did mention this, Paige.
Yes, absolutely. So just to elaborate on that, we've also designed the system, for example, for construction, and we have a whole inspection module that's built into the system. And of course, when you're doing inspections, there's kind of a continuous workflow process where you need to make continuous notes as you're capturing the point. So the answer to that question is yes.
Okay. So Richard P. asks, how does the ProStar app handle, locate, and track PVC lines that don't have a magnetic tracer present? The example with the EML locator with the app, but you've designed it so you could bring in data by many other means, correct?
You can. Yeah, we integrate into all the locate devices. As I mentioned, primarily we're relying on the information that's coming from the EM locate tool. But he's right. I mean, there's limitations. If you don't have a tracer wire on PVC, it's very difficult to be able to identify the PVC material. However, and again, I'm not an expert on even EM locate tools, but there's a lot of advancements that's being made in these locate devices, including the ability to identify PVC. And I'm sure over the next year or 2 years, because technology advances so rapidly, I think that'll be an issue that eventually will be addressed.
Okay, great. Now, Polkit C, he has asked, is it EML technology, which is the majority used for locating subsurface utilities, or GPR, well, mostly used in your experience with your end users?
Well, it's mainly the EM locate tools, and the reason is because currently the way the business practices is through the one call center is they have to go out and locate and identify where these lines are. The challenge is they're currently just putting paint marks down and flag markings, and there's billions of points that are collected every year, are not collected, if you will, marked. And I think that what we need to start doing is collecting those points with a high level of precision, because then we can identify precisely where those lines are, and then we can update all the information at the 811 center, and then subsequently the utility owners and pipeline owners could then update their records, and this is what would significantly reduce the amount of damages that are inflicted on these utilities and pipelines every year. But the main source for identifying where the lines are today is EM locate tools.
Okay, great. Somebody's asking to talk a little bit about your partnership with Centerline.
Yes. What is the partnership?
Yeah, a little bit.
So Centerline is a company that specializes in training, field data collection, and the ability to identify, capture, record, and map, where these utilities and pipelines are buried below the ground. And they do a great job. And they asked if they could partner with us and use the PointMan software for their training purposes, which of course, just identifying the synergies between the two companies, we realized that it would be a great partnership. And so we agreed to provide them the ability to utilize PointMan as their training software.
Okay, great. So Joseph P. asked, if I run a utility and want to use the ProStar product, how can I be certain there is a good database that PointMan can access so that it can pay for itself?
You might have to elaborate a little bit on that question, because I think it centers around the database, and I want to understand that question a little better before I answer it.
Yeah, I quoted it verbatim. I still
maybe
wasn't
just repeat
sure.
it again. Maybe just repeat it one more
Okay.
time.
If I run a utility and want to use the ProStar product, how can I be certain that there is a good database that PointMan can access so that it can pay for itself?
Okay, so number one, PointMan is our mobile application that you can buy as a standalone product. But we also have Transparent Earth, which is the whole back-end database management system. Now, with PointMan, you can also utilize PointMan to integrate into any other GIS system, including just utilizing Google Earth or Esri or CAD systems, say for example, like Autodesk or Bentley. So as I mentioned before, it's designed to work with any other current legacy hardware systems or software systems that are out there. But we've also built Transparent Earth, which is a very low-cost cloud solution, and it's a GIS and CAD system, if you will, built into one.
Oh, okay. A question, can you utilize different GNSS hardware for the positioning?
Absolutely. So we're integrated into several of the GPS and GNSS hardware manufacturers, EOS, Blue Star, Emlet. There's several of them out there. As I mentioned, we can pretty much seamlessly integrate into any hardware solution that's on the market, including GPS, GNSS, GPR, the EM locate tool manufacturers. We work with all of the majority hardware providers.
Okay, yeah, it would appear that if you have a GNSS antenna or receiver with corrections as a peripheral and it's getting high precision, if the NMEA output can go to your app on the phone, direct or mock location, that would appear it could be almost any, or is there some level of integration that would be needed?
No, in most cases, most of the tools that are manufactured today have the ability to pair through Bluetooth. And a lot of these companies, what they'll do is they just have to provide us their SDK, so we have the ability to pick up, you know, their unique connectivity, and then we can seamlessly integrate it into PointMan.
Okay, a question from Ryan W. Is PointMan working in Canada?
Absolutely, we have clients in Canada. PointMan works anywhere in the world.
Okay. A question again about the Catalyst. Do you have to post-process for centimeter level using Catalyst? Well, I can answer that, but you can as well. No, you do not have to if you have real-time correction.
No post-processing required. That's one of the things that we set out to eliminate immediately, was the need to post-process. So anything that's captured in the field is real-time available out onto any other mobile device or back to the office, and it's already processed.
Okay. Question from Tyler B. Is there any training available on using PointMan and GIS mapping software that it could be feeding as well?
Yeah, absolutely. That's what I mentioned is, you know, there's companies out there like Centerline Mapping that specialize in training in data collection software, geographic information systems. And that's one of the reasons why we partnered with Centerline. I mean, honestly, I would say Centerline does a much better job in even training on our own software. And it makes sense to partner with companies that have a core competency, you know, in whatever their service offering is. And, you know, that's one of the reasons why we partnered with Centerline.
Okay, well, actually, yeah, somebody just put on a software-specific question. Can the collected data be processed into MicroStation GeoPack software?
Yes, it can.
Okay. Yeah, it's yeah, spatial data is you know, mostly very compatible, or you import and export, or actually more and more direct link into, you know, you've got LandM XML formats and so many others. It's pretty much, if the data is there and it's good, there's a way to get it in and out of other packages.
Well, just to elaborate on that, Gavin, I mean, obviously, you know, Esri, Autodesk, Bentley, they have their own file formats, but they've opened up those file formats. So, you know, your CSV files, as you mentioned, KML, XML, almost all of the, you know, hardware and software providers are becoming, you know, very open and using open standards so that you can share data. And as a result of that, I think that, you know, there's a lot more collaboration that exists. And also, you don't have to change your business practices. So if you're using an Esri system and you're using Trimble, you know, data collection hardware, and someone like ProStar comes out with a new software solution, inherently it will work with those other solutions. So you don't have to change what we call your legacy business practices, because that can become very expensive.
And that's really critical now, you know, with infrastructure development ramping up all over the world. There's no such thing as a sort of a greenfield project with one brand. You've got subs, the GC may have so many different subs that they're all dealing with different software, and this openness, as you said, opening up SDKs in software to allow that. And as Jeff Zeiss said in his session, the open data is the key to getting it all to have complete underground data sets. So another direct question about that, has that integration with Bentley software has been tested? Do you have a user doing that at this point?
Yes, we do. As a matter of fact, I'll have Rob can even elaborate on that a little more, but we work very closely with several DOTs, including Colorado DOT, and the DOTs use several different solutions, several different GIS solution packages, and several different CAD systems. And the reality of it is we have to integrate into all of them, because eventually the data that's being collected is being utilized by various different departments, and those various different departments use different GIS and CAD systems. So we have to integrate into all of them.
Excellent. That's right. We're going to be here from Rob Martindale with the Colorado Department of Transportation next case study. So A question about, as per the Federal Highways Administration, amount of investment that goes into locating subsurface utilities is nearly 1% of the design and construction phase investment. Any comments on this? Or could you elaborate on it? Is the value different in different regions?
I think it's different in different regions. I think that investment should be a little higher because of the damages that are incurred during these large infrastructure construction projects. As I mentioned, we work with some of the largest construction companies in the United States that are developing out infrastructure, and they put a lot of money into identifying where these utilities are buried below the ground, because in most cases, it's the construction company that actually takes on the risk. They're liable for hitting those lines, which can be very expensive, especially if you're talking about, fiber optic lines, and gas lines, petroleum lines that are very damaging if you strike those lines. So I think what we're going to see is actually an increase in spending as far as percentage of the project and identifying where these lines are, because it's becoming a very, very big problem. And what we're going to see now, there are discussions of spending, $2 to $3 trillion in infrastructure. As I mentioned, every time you go out and do improvements on the above ground infrastructure, there's a high probability that you're going to damage what's buried below the ground, which is far more complex and greater in size. So as we start to see more construction and surface infrastructure, we could potentially see a lot more damages on what's buried below the ground. So I think we're going to have to spend a little bit more money on identifying what's buried, down there before we start any type of large construction projects.
There has to be a hammer behind it, and as you said, if the contractors, if the GC has liability in that, that's a good hammer. So here's a question just came in. Would you envision a warehouse database to store and retrieve mapped utilities? I think that's kind of what Jeff has been describing about in different places in the world, like in Colorado.
Yeah, so I could see at some point in time, there's going to have to be a centralized data warehouse, if you will, that can be shared by all of the stakeholders. So, 811, at the government level, including local, also federal government, municipalities, utility companies, pipelines. There's going to have to be some type of system where everyone can share their data. And in fact, that's what ProStar has developed. And we're working with government agencies. We're working with 811. It's called the Holy Grail. Everyone's looking for a centralized database where all of this data can be contributed and managed. But then the biggest question comes up is, privacy issues and security issues. And we can address that as well. I mean, our goal is at state and federal level is to actually provide the ability to have a centralized database. And we're slowly working towards that. It requires a large effort, not just by ProStar, but a consortium, if you will, of people that are willing to contribute their data. But if you're on a project site and everybody was willing to share their data, and you could geo-reference it and determine based on permissions and privileges on who sees that data, can they edit it, can they view it only, and you develop that system. Through sharing the data, we could significantly improve, if you will, the mapping of the underground and significantly decrease the amount of damages that occur every day. And we're working towards that, and I'm very confident that we're going to get there. When, I'm not sure, but we're slowly working towards that, and we have more and more companies and stakeholders that are trying to accomplish the same goal, and they're also willing to contribute data.
Excellent. Yeah, we've seen more movement in this direction in the past couple of years than I've seen in decades. So it's very promising. Thank you again, Paige. Another great presentation and answering the questions.